fundamentals. So see, in fundamental study during last lecture, we have studied the uniaxial, biaxial and triaxial stress system. At the same time, we studied the uniaxial, biaxial, triaxial strain system also. So how the relationship between the stress as well as strain in uniaxial, biaxial and triaxial stress system that is established, that we have seen, and how to identify stress as well as strain. Is it okay? As far as concerned with this three-dimensional stress analysis, some fundamental part with the reference of triaxial stress system that we are going to see. But before that, we are aware about different relationship between the elastic constants. So, which are the different elastic constants to whom we are calling as elastic constants? Elastic constant आपण कोणाला म्हणतो? What are the elastic constants? E, mu, G and K. These four are elastic constant. What is meant by E? E means, what is meant by capital E? E means which kind of elastic constant? Yes, please, anybody? That is mu. That is G and what is K? Am I audible? Am I audible? माझा आवाज येतोय का? What is meant by E? E is Young's modulus or elastic modulus or modulus of elasticity. What is mu? Mu is Poisson's ratio. Mu is Poisson's ratio. What is G? G is shear modulus or modulus of rigidity. And K is bulk modulus. So E, mu, G, K, these are four elastic constants. And why these four elastic constants are required? Because that four elastic constants will decide the property of that material. Whatever may be the available material in the universe, for each material, these properties are present. And with reference to that properties, we are identifying the nature and behavior of that material. How this material will behave when tensile load is applied, compressive load is applied, or in torsion, or in buckling, or in bending, how this material will behave. In order to understand the behavior of that material, response of that material, we required the four elastic constant, and that elastic constants are E, mu, G and K. And unless and until we don't know that elastic constants, we cannot predict the behavior of the material. Is it okay? So already all of you are familiar with these elastic constants, and besides these elastic constants, so here we have already established the relationship between them. Is it okay? What is the relationship between them? As far as concerned with E and K, and as far as concerned with E and G, what is the relationship between E and G? E is equal to 2G into bracket 1 plus mu. E is equal to 2G into bracket 1 plus mu, where E is what, G is what, and mu is what? Yes, please. E is equal to
E
2G. Huh. Yes,
is
yes, yes.
E is equal to Young's modulus, G of rigidity,
Yes, 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 yes. And mu is Poisson's ratio. Is it
Poisson's
okay?
ratio.
So, yes, correct. So E is equal to 2G into bracket 1 plus mu. Similarly, another relationship between E and K. What is the relationship between E and K? E is equal to 3K into bracket 1 minus mu. Is it okay? E is equal to 3K into bracket 1 minus mu. So here M is one of the factor which is shown here. This M is the reciprocal of Poisson's ratio. Is it okay? Here M is considered to be a reciprocal of Poisson's ratio. So the first equation between E and G is E is equal to 2G into bracket 1 plus mu. And second relationship between E and K is E is equal to 3K into bracket 1 minus mu. Is it okay? Are you getting these two equations? Already you are familiar with this. You have studied this in your second year. And the third equation between E, K and G is equal to E is equal to 9 kg upon 3K plus G. Is it okay? E is equal to 9 kg upon 3K plus G, where E is Young's modulus or elastic modulus or modulus of elasticity, K is bulk modulus, and G is shear modulus. Is it okay? So that is the relationship between EZ and K. Is it okay? So all these together relations are shown here. E is equal to 3K into bracket 1 minus 2 nu. E is equal to 2G into bracket 1 plus 2 nu, and E is equal to 9 kg upon 3K plus G. Is it okay? So this relationship between elastic constant which is shown here. Is it okay? Now let us observe this particular figure. All of you please check this figure, see this figure. Okay, you are observing this figure now. So with this figure, let us check now different component, and already we called that stress is a tensor. Is it okay? In first lecture, we discussed about stress as a tensor. What is tensor quantity? So tensor is the quantity which is having more than one directions magnitude with respect to different directions. So that is we are considering to be a tensor quantity. Is it okay? So with this, let us see here this particular figure in which this direction is considered to be x direction. Is it okay? Then this another direction here it is considered to be y direction. Here y direction is shown, and this vertical direction here it is z direction is shown. Is it okay? So x, y, and z. These are three mutually perpendicular axes, and this particular block is taken for this study. Is it okay? All of you are observing this particular block for which the directions x, y, and z in all three directions, how the component of forces, because up till now whatever the figures we have studied up to our solid mechanics or in strength of material, all these figures were considered to be a two-dimensional figures. Is it okay? There were no any kind of three-dimensional figures, but here you can observe these different stress components. As far as concerned with this sigma xx, this sigma xx is the stress along x-axis. So this sigma yy is shown here. So sigma xx for this positive x-axis is shown, sigma xx negative x-axis is also shown. Then here you can observe the sigma yy. So along this y direction, in the direction of y, the parallel to this y direction, here sigma yy is shown. Similarly, here also this sigma yy is shown. Is it okay? So sigma yy and sigma xx. So both directions, which are now this sigma axis, negative x-axis, positive x-axis, negative x-axis. Similarly, positive y-axis and negative y-axis in both the direction, that sigma yy is there. And then sigma zz, inside that this positive z-axis and negative z-axis in both the directions, that sigma zz is also present. So sigma xx, sigma yy and sigma zz, all three directional stresses that are shown here. Is it okay? Then shear components you can observe here. What are the shear components? You can see here that components here, a component of x in the z direction. Now these components you should understand, because this is very important. Hereafter you should know that how these different components are present. On this particular subjects, three components are there. On this surface, there are three components. Similarly, on this remaining three, it is on this surface also three components. On this surface again three components. So this four surface, again this top surface, and this is bottom surface. So all six surfaces there. Each and every surface, the three component of forces are shown. So that three component of forces on each surface, that becomes to be a 18 total component of stresses. Is it okay? You can observe here the 18 component of stresses. So this one is positive x-axis, this one is negative x-axis. Vertically, this is positive z-axis, negative z-axis. So these four stresses which are shown here, these four stresses are considered to be a direct stress. So directs positive x, directs negative x, directs positive y, negative y, z and z. Likewise, on each surface if we count, then this will become 6. For each and every surface, one direct stress component. So x direction, positive x direction one component, negative x direction one component. Positive x, y direction, negative y direction. Positive z direction, negative z direction. Likewise, the 6 components of the direct stresses that are available here. Now, if we see for the each and every component of stress by taking the reference of other component, means here if we check, now we will start with this particular surface. On this surface along direction x, this stress is present. Is it okay? Then if we consider here, then this is sigma zx. So what is sigma zx? Sigma zx is the component of stress of on the surface on which this xx stress is acting along z direction. Is it okay? Zx, here you can see the direction. Here you will observe the direction. By observing this direction, you will come to know that this particular direction is the direction parallel to z axis. Is it okay? This is the direction parallel to z axis. Here you can see this is the component direction which is parallel to z axis, but this is the component of x along z direction. This is the component of x along z direction. Similarly, if we look to this particular component, then this is moving in which direction? This particular arrow is moving in which direction? This arrow is moving in the direction of y. Is it okay? This particular arrow is moving in the direction of y-axis, parallel to y-axis. So that's why this will be the component of x along y-axis. Is it? So that's why this will become a sigma yx. So this is sigma zx. So this is vertically sigma zx. This is the sigma yx, and this is sigma xx. So the component of force in the direction of x, component of force in the direction of directly x in the component of force directly in the direction of, here you can see that particularly in the direction of z, and this is the component of force in the direction of y. So you can understand this. Are you getting this particular component of forces, sigma xx, sigma zx, and sigma yx? So three component of forces you can understand here. At the same time, in the opposite direction, okay, in opposite direction, if we'll check, then sigma x is negative x-axis, on that sigma x-axis is present. So here sigma zx is present, but this particular, sorry, x component of x along z direction. Is it okay? So zx and component of this, so that you can check here. Is it okay? So these are the component of forces which are in the particular direction. Are you getting? Just please check once again. Are you getting this particular component forces? Okay, so with this, you can see here that this particular sigma xx is the component of stress acting in the x direction. So the component of stress acting in the z direction. So component of x along z direction, component of x along y direction. Are you getting this? Yes or no?
Yes.
All of you, please say yes or no. Only I am getting one answer. Other students, are you getting this particular concept or not?
Yes, sir.
So this is the sigma xx. This is the direction of only direct stress. Positive x-axis, negative x-axis. This is component of this particular x in the z direction. This is the component of x in the y direction. Is it okay? Similarly, if we take this top surface, is it okay? If we take this top surface, the perpendicular to that top surface, this is the vertical perpendicular to this top surface. So this is definitely sigma zz. Is it okay? Are you getting this particular component? This is sigma zz. This is the direct stress along z axis. This is the stress acting along z axis. Then component of z along x axis and component of z along y axis, because this particular direction is x axis. Component of z along x axis is shown by sigma xz, and component of z along y axis is shown by sigma yz. Is it okay? Are you getting this particular concept here? Component of z along x axis and component of z along y axis. You can understand? Are you getting this? Are you getting this? तुम्हाला हे लक्षात येते का? हा डायरेक्टली स्ट्रेस आहे तो व्हर्टिकल डायरेक्शन मधला आहे, त्याला झेड झेड असं म्हणलं आपण, कारण या सरफेसला परपेंडिक्युलर डायरेक्शन मध्ये तो ऍक्ट होतो. दिस इज द perpendicular direction, and on this perpendicular direction this stress is present. Is it okay? So in the direction of z axis, positive z axis and negative z axis, and this one is the component of stress along x axis. This is the component of stress along y axis. The component of z along y axis. Is it okay? Are you getting this concept? Yes or no? Yes, sir. Okay. Bharti Sawant is giving answer as a yes. Others, are you getting or not? हा कन्सेप्ट लक्षात येतोय का बघा, याच्या पुढे जायचंय आपल्याला. Say yes or no. If you will say no, no problem. I will explain once again. But if you don't remain as it is, otherwise I will consider that you are not giving attention to the lecture. बाकीचे नुसते म्यूट करून बसू नका, फक्त रिस्पॉन्ड करा जरा. आर यू गेटिंग और नॉट गेटिंग? हा कन्सेप्ट तुमच्या लक्षात येतोय का? माझा आवाज तुम्हाला येतोय का आणि हा कन्सेप्ट लक्षात येतोय का? दोन प्रश्न आहेत, पटकन उत्तर द्यायचं. नरेंद्र शेटे. नरेंद्र शेटे. अरे पटपट बोलता येत नाही का रे तुम्हाला? एवढा उशीर का लागतो रे? प्रफुल्ल केदार. प्रत्येकाचं नाव घेऊन बोलवायला लागतं. तुम्हाला एकदा कॉमन विचारलं किंवा समजते का नाही समजते? पटपट बोलता येत नाही का रे? राजकुमार चव्हाण. हा. स्मिता चौगुले.
Yes, sir.
सुजाता बिंगे.
Yes, sir.
आर यू गेटिंग दिस?
Yes.
तुमच्या लक्षात येते का हे? हा ठीक आहे. हे चार जे डायरेक्ट स्ट्रेस कंपोनंट आहेत, एक्स डायरेक्शनचा स्ट्रेस, पॉझिटिव्ह एक्स ऍक्सिस, निगेटिव्ह एक्स ऍक्सिस, पॉझिटिव्ह झेड ऍक्सिस, निगेटिव्ह झेड ऍक्सिस, पॉझिटिव्ह वाय ऍक्सिस अँड निगेटिव्ह वाय ऍक्सिस. इज इट ओके? These are the direct stresses and the component of that particular stresses along other directions. आता हे टेंजेन्शियल जर असतील तर हे शिअर स्ट्रेस असतील, पण त्या पर्टिक्युलर कंपोनंट जो आहे हा वाय डायरेक्शन मधला, म्हणजे स्ट्रेसचा वाय डायरेक्शन मधला जो कंपोनंट आहे, तर तो कंपोनंट आपण काय म्हणतो? सिग्मा वाय झेड, सिग्मा एक्स झेड. सिमिलरली हिअर component of this z along x direction is xz, component of this z along y direction is sigma yz. हे सगळ्या सरफेस वरचे लक्षात येत आहेत का? आर यू गेटिंग दिस कॉम्पोनंट्स? ऑल कॉम्पोनंट्स, हे सगळे कॉम्पोनंट्स लक्षात येत आहेत का सगळ्यांच्या? येस और नो?
येस सर.
ओके, थँक्यू 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 फॉर युअर रिस्पॉन्स. जरा बोलत राहा, तुम्ही बोलल्याशिवाय मला पुढे जाता येणार नाही. तुमचे चेहरे मला दिसत नाहीत, त्यामुळे तुमच्या आवाजावरून मला लक्षात येणार आहे कळते का नाही ते. ओके. Now let us go for the next part of this one, which is considered to be an equilibrium equation. Is it okay? Equilibrium equation असं म्हणतो आपण त्याला. So equilibrium equation means this particular figure. First of all, you should understand this figure. So this may be, or you may refer this figure also. So in this figure, you are going to observe that a small component is taken for study, and this small component is A, B, C, D. Is it okay? This is the small component which is taken for this study. Is it okay? So this is positive x-axis, this is positive y-axis, and small component we have taken for this study, which is A, B, C, D. Is it okay? The A point is considered to be a reference point. Now, this small piece with small component dx and dy. Is it okay? So dx is the dimension which is considered in the x direction, and dy is the dimension which is considered in the y direction. Is it okay? So x and y, what is it represents? That the small piece along x direction is dx and small piece along y direction is dy. So small piece is cut with any stressed component with the dimension dx, small, infinitesimally small dx and infinitesimally small dy, that is taken for study. This small piece is considered to be A, B, C, D as shown in this figure. Now the reference point which we are choosing, this the reference point is point A here. Is it okay? So this reference point is our point A, and B is at a distance dx from this point A. Is it okay? So point B is at a distance x. Here you can check, here you can see here. So here also in this figure you can see that this is point A, B, C, D. Is it okay? You are getting this A, B, C, D in this particular figure. If you see, this is the reference point A. This is point B. This is point C, and this is point D. So from this point A at a distance x dx. So dx is the small distance from the point A to point B. Then distance dy from B to C. Is it okay? So this is a reference point A, this is a reference point B, this is a reference point C, and this is a reference point D. All these 4 points are present here. So what that 4 points are indicating? These 4 points are indicating, so this is the corner points of selected component, and dimension along x-axis is given by dx, and dimension along y direction is given as dy. Means distance between A and B is shown as a dx, and distance between B and C is shown as dy. Okay. Now say A point, as it is a reference point, we have considered to be a stress at point A as a sigma x6. Is it okay? Stress at point is sigma x6. Then I want the stress at point this B. Is it okay? I want the stress at point B here. The stress at point A we are considering sigma xa. Stress at point B we are considering sigma xb. Stress at point C we are considering sigma xd, and stress at point D we are considering sigma xd. So these all are stresses at point A, B, C, and D. Now we are identifying these stresses. We are now going to identify these stresses. So stress at point B. Now the stress at point B is considered to be sigma xb. When sigma xb with reference to A point we are going to identify. Is it okay? So whatever the stress present at point A plus from A to B. Now if suppose we take into example that suppose big building is there, then whatever the stresses at the bottom, same stresses will not be at the top. Stresses will be different. There may be the different geometry, there may be the, we may consider that environmental parameters are there, or geometrical parameters are there, or gravitational parameters are there, or some another different maybe the reasons due to which this nature will be statistical. Is it okay? So at each and every point stress will be different. So stress at point A, which is different from B, which is different from C, and which is different at point D. Is it okay? Because different parameters are acting on each and every point, so there is small difference at these different locations. So reference point, as we have considered to be A is the reference point. Then with respect to A, at point B, what is the stress? That stress is sigma xb. Then what is sigma xb? Sigma xb is considered to be sigma xx plus dou sigma xx. See here, it is a differential equation with reference to A. At point B, we are considering the differential equation, and that differential equation is with reference to X. So we are taking differentiation of the sigma xx with respect to X over this distance dx. Is it okay? So over this distance dx. So you can understand here that at point A and at point B, how it is different. So at point B, it is sigma xb, and sigma xb is the stress at point B, which is influenced by the position which is at a distance of dx from A. So that's why we are taking the differential equation, because B point is exactly in the direction of x from A. So that's why we are considering the partial differential equation, and that partial differential equation is considered to be a differentiation of this sigma x at point A with reference to x at a distance of dx. So that's why the stress present at point B is considered to be sigma xx plus dou sigma xx upon dou x into dx. Are you getting this particular equation number 1? Yes or no? Amit Moite. Amit Moite, am I audible? Amit Mohite, am I audible?
Yes, sir.
So what I am telling, are you getting this? मी काय म्हणतोय लक्षात येते तुमच्या? तुमच्या लक्षात येते का? Yes or no? All of you, are you getting this or not? पुन्हा एकदा रिपीट करू द्या का?
हा सर.
हा, पुन्हा एकदा रिपीट करतो, लक्षात घ्या. ए पॉइंट पासून थोडस बोलत राहा. ए पॉइंट पासला जो स्ट्रेस आहे त्या स्ट्रेसला काय म्हणतोय आपण? ए पॉइंट पाशी असणारा स्ट्रेस आहे त्या स्ट्रेसला काय नाव दिलंय? एनीबडी? Yes, please. Please speak, otherwise I will not get you are getting understanding or not. At point A point पाशी असणारा जो स्ट्रेस आहे त्या स्ट्रेसला नाव काय दिलंय? सिग्मा एक्स ए और सिग्मा एक्स एक्स. काय नाव दिलंय? पुन्हा एकदा रिपीट करा.
सिग्मा एक्स एक्स.
सिग्मा एक्स एक्स किंवा सिग्मा एक्स ए हे ऍट पॉइंट ए असणारा स्ट्रेस आहे. आता त्या रेफरन्सने आपण काय करतोय? त्या रेफरन्सनी बी पॉइंट पासला स्ट्रेस आपण आयडेंटिफाय करतोय. मग त्या रेफरन्सनी बी पॉइंट पासला स्ट्रेस जर आपल्याला आयडेंटिफाय करायचा असेल, बी पॉइंटचा स्ट्रेस आपण कन्सिडर केलाय सिग्मा एक्स बी. बी पॉइंट पासला स्ट्रेस आहे त्या स्ट्रेसला काय नाव दिलंय? कोणीतरी रिपीट करा.
सिग्मा एक्स बी.
Sigma xb. Sigma xb is the stress present at point B. हा स्ट्रेस आपल्याला आयडेंटिफाय करायचा आहे. आपला रेफरन्स स्ट्रेस जो आहे तो ए पॉइंट पाशी आहे, आणि त्या रेफरन्स स्ट्रेसला ए पॉइंट पाशी आपण नाव दिलंय सिग्मा एक्स एक्स, आणि बी पॉइंटला दिलंय आपण सिग्मा एक्स बी. तर सिग्मा एक्स बी आयडेंटिफाय करत असताना सिग्मा एक्स एक्स या रेफरन्सने आपण तो आयडेंटिफाय करतोय. तर तो आयडेंटिफाय करत असताना सिग्मा एक्स बी बरोबर काय? तर सिग्मा एक्स एक्स प्लस dou sigma x upon dou x into dx. येस, पुन्हा एकदा रिपीट करा, मला कोण सांगेल? सिग्मा एक्स बी. सिग्मा एक्स बी काय आहे? सिग्मा
sigma x plus dou sigma x.
सिग्मा एक्स प्लस डो सिग्मा एक्स अपॉन डो एक्स इंटू डीएक्स. सिग्मा
sigma x plus dou sigma x upon dou x plus
इंटू डीएक्स. आता
into dx.
या प्रत्येकाचं लॉजिक आपण समजून घेऊया. वी विल अंडरस्टँड द लॉजिक. हे लॉजिक काय आहे बघा. सिग्मा एक्स बी म्हणजे काय? व्हॉट इज सिग्मा एक्स बी? व्हॉट इज सिग्मा एक्स बी? व्हॉट इज सिग्मा एक्स बी? प्रफुल्ल कुमार केदार, आवाज येत नाही तुमचा.
स्ट्रेस एट बी.
स्ट्रेस ऍट पॉइंट बी. बरोबर, स्ट्रेस ऍट पॉइंट बी. सिग्मा एक्स बी हा स्ट्रेस ऍट पॉइंट बी आहे. आणि सिग्मा एक्स एक्स काय आहे?
पॉइंट एट चा स्ट्रेस.
सिग्मा एक्स एक्स काय आहे?
रेफरन्स फॉर
रेफरन्स किंवा स्ट्रेस ऍट पॉइंट ए म्हणूया ना आपण त्याला. किंवा ए पॉइंट पासला स्ट्रेस किंवा रेफरन्स स्ट्रेस असं म्हणलंय आपण त्याला. सिग्मा एक्स ए म्हणजे सिग्मा एक्स एक्स आहे, हा रेफरन्स पॉइंट पासला स्ट्रेस आहे. सिग्मा एक्स बी हा बी पॉइंट पासला स्ट्रेस आहे. आता बी पॉइंट पासला स्ट्रेस आपण कॅल्क्युलेट करतोय. सो सिग्मा एक्स बी इज इक्वल टू सिग्मा एक्स एक्स प्लस डो सिग्मा एक्स एक्स अपॉन डो एक्स इंटू डीएक्स. लक्षात येते का बघा? व्हॉट आय एम टेलिंग यू. सिग्मा एक्स बी इज इक्वल टू सिग्मा एक्स एक्स plus why we are adding this particular component here? Because our assumption is that due to location difference, due to uncertainties, or due to some undefined parameters, there may be this stress different at different locations. Means whatever the stress present at point A and the stress present at point B may be different due to its different location. So B point is at a distance dx in the direction of x from point A. B point हा A point पासून dx एवढ्या डिस्टन्स वरती आहे आणि ए पासून डीएक्स एवढ्या पोझिशनल डिफरन्स मुळे बी पॉइंट पासला स्ट्रेस हा थोडासा वेगळा असेल. तो आपण आयडेंटिफाय करतोय. तो आयडेंटिफाय करत असताना आपण काय करतोय की रेफरन्स पॉइंट ए पकडतोय. विथ रेफरन्स टू ए स्ट्रेस ऍट पॉइंट बी वी वॉन्ट. सो दॅट्स वाय स्ट्रेस ऍट पॉइंट बी विल बी इक्वल टू स्ट्रेस ऍट पॉइंट ए प्लस differential equation of stress at point x with respect to x and from distance dx. That's why this particular additional part we are adding there. Is it okay? On screen you can see this is the additional part which we are adding in sigma xx. Sigma xa is sigma xx only, but sigma xb is equal to sigma xx plus dou sigma xx upon dou x into dx, where dou sigma xx upon dou x is nothing but the differential part which is added with reference to a at point b. So differentiation of sigma xx with respect to x and at a distance of dx. Is it okay? Yes or no?
Yes, sir.
Yes, sir.
Very good. So this is the stress at point B
B.
that we can understand here. So sigma xb is nothing but sigma xx plus dou sigma xx upon dou x into dx. That represents, this additional part represent differentiation of stress x with respect to x at a distance of x. That's why this additional part we have added in here sigma xb. Is it okay?
yes sir.
Okay.
Okay, very good. So let us go for next point now. Now see, We want the stress now at point D. Whatever the logic we have developed to identify the stress at point B, same logic now we are going to develop at point D. So sigma xd, what is the sigma xd here? Sigma xd at this point is nothing but the stress present at this point A, which is sigma xx, but now this is vertical. Is it okay? Here this is vertical direction, and as this point D is vertically upward in y direction to D, so that's why we are going to take differentiation of sigma xx in the direction of y with respect to y, and this particular distance is given as dy.
dy.
Yes, so that's why here, while identifying this sigma xd, now what references we are considering? Sigma xx is the stress present at point A. Differentiation of sigma xx with respect to y at a distance of y. So here this you can see that this additional part is added here. So this additional part you can understand dou sigma xx upon dou y into dy. Is it okay? Are you getting? In that sigma xx, what we are adding? We are adding here dou sigma xx upon dou y into dy. Is it okay or not? हे लक्ष देते का नाही?
Yes, sir.
Yes, sir.
Okay, very good.
Yes, sir.
Very good. Yes, thank you. So, the stress present at point D, for that we have added this particular part, which is considered to be a part of partial differentiation, as a part of uncertainties, as a part of positional difference, as a part of its nature due to its presence. So, stress present at point D, which is influenced by this particular component, which is considered to be a partial differentiation of sigma xx with respect to y at a distance of y. This dy represents the distance. Dy is the distance of D point from A. Is it okay? So that's why this is influenced by this particular total parameter, in which differentiation of x with respect to y at a distance of y, that is shown here. Is it okay? So stress present at point D is equal to sigma xx plus dou sigma xx dou y into dy. So this particular equation 2 that we will get here. So equation 1 is the stress present at point B. Equation 2 is the stress present at point D. Are you getting these two equations? हे दोन्ही पण equations लक्षात येत आहेत का? नसतील तर नाही.
Yes, sir.
Yes, sir. Okay, very good. Others?
Yes, sir.
Yes,
Yes.
Narendra, okay. Very
Yes, sir.
good. Very good. Okay, thank you. So now coming to the end part, that now one equation is only remaining, that is stress present at point C. At point A reference point, that's why sigma xx. xb साठी आपण काय केलं तर डो सिग्मा xx अपॉन डो x इंटू dx केलं. इथं फक्त काय केलं त्याच्यामध्ये ऍड डो सिग्मा xx अपॉन डो y इंटू dy केलं. सो डी पॉइंट साठी आणि बी पॉइंट साठी आपण रेफरन्स पॉइंट पकडलेला होता ए पॉइंट. वी हॅव कन्सिडर्ड द रेफरन्स पॉइंट एज ए पॉइंट. Now, for this point C, in order to identify the stress at point B, now we are considering this sigma xb as a reference point. Is it okay? Now we are considering sigma xb as a reference point. So with reference to this sigma xb, now we are going to identify stress at point C. Is it okay? So here you can understand that at point this sigma xc, is it okay? The stress at point C is nothing but stress present at this point B plus, now C is present in which direction of B? C हा B च्या कोणत्या डायरेक्शनला आहे? X का Y डायरेक्शनला आहे?
Y
Y
direction.
direction.
वाय डायरेक्शनला. व्हेरी गुड. सो वाय डायरेक्शनला असल्यामुळं सी हा पॉइंट बी पासून वाय डायरेक्शनला असल्यामुळं डेफिनेटली या एक्स बी चं डिफरन्शिएशन घेत असताना आपल्याला कसं घ्यावं लागेल, विथ रेफरन्स टू वाय घ्यावं लागेल. इज इट ओके? सो हिअर we will take the differentiation of this sigma xb with reference to y and at a distance of y. Is it okay? So how this total equation now will get generated? See here, sigma xc is nothing but stress present at point C here, and this sigma xb is the stress present at point B, which is in which this particular part is added, and this part is nothing but the differentiation of this sigma xb with respect to y and at a distance of y. Is it okay? With respect to y and at a distance y. So that's why sigma xc is nothing but sigma xb plus dou sigma xb upon dou y into dy. So with this particular third equation is given here. या इक्वेशन मध्ये या इक्वेशन लक्षात येते? इक्वेशन 3 लक्षात येते का?
Yes, sir.
ऑल अदर्स बाकीचे?
Yes, sir.
Okay, all of you are getting this particular equation. So sigma xc is the stress present at point C, and with reference to B, we are considering sigma xb plus dou sigma xb upon dou y into dy, because at a distance of y it is present, and that's why this particular equation will exist here. The stress present at point C is nothing but stress present at point B plus differentiation of the stress present at point B with reference to y at a distance of dy. Okay. So here now small addition or small substitution we are going to make, because in this three equation we have identified stress present at point C, and here we have taken the reference of stress present at point B. Now let us substitute this particular equation 1, because equation 1 which is shown here, this equation is 1 is for sigma xb, stress present at point B. So this is the stress present at point B, and that's why this equation 1 we are going to substitute here. Is it okay? So this particular equation 1, if we substitute at this location, then what we will get? We will get the sigma xc. So sigma xc is equal to nothing but this particular sigma xb, which is replaced here with this equation 1, or equation 1 is substituted in this equation 3, then what we get? We get that sigma xx, because one equation for that sigma xx plus dou sigma xx upon dou x into dx plus dou by dou y of sigma xx plus dou sigma xx upon dou x dx. Is it okay? Here what is done? Here at this sigma xb, whatever the equation 1, that is substituted in this equation 3 at this sigma xb also and at this sigma xb also. At both the locations we have substituted sigma xx plus dou sigma xx dou x into dx. So this particular equation 1 is substituted at both these locations in order to get this particular equation, next equation. So now here we are going to simplify it. So when we will simplify, what we will get? See here, sigma xx plus dou sigma xx upon dou x dx. Now here it will come dou sigma xx upon dou y into dy, and this one as a dou 2 sigma xx upon dou x dou y dx dy. But as higher order terms that are always smaller, we should neglect it. Means what? Already we are taking this differentiation of the term, and we are multiplying with dx and dy. Dx and dy both are very small components, and then again we are taking its a double differentiation. Is it okay? If we take the example of 0.1, 0.1, if we take square of 0.1, then what will it be? It will become 0.01. It will become. If we take the 0.01 square, then it will become 0.0001. Is it okay? So higher order terms of smaller components are always very, very small. And that's why this say higher order term, this is neglected here. Is it okay? So this particular higher order term, neglecting that, what we are getting? We are getting here this particular sigma xc is nothing but sigma xx plus dou sigma xx upon dou x dx plus dou sigma xx dou y dy. Is it okay? So this particular term will get, and this higher order term, higher part, that is neglected here. Is it okay? Now we are getting this as equation number 4, and equation number 4 which represent stress at point C. Equation 2 represents stress at point D, and equation 1 represent stress at point B. Is it okay? इथपर्यंत लक्षात आलं का? इथपर्यंतचा पार्ट लक्षात आलं का?
Yes, sir.
Yes or no?
Yes, sir.
ओके. सगळ्यांच्या लक्षात आला?
Yes, sir.
ओके. राजकुमार चव्हाण.
आले सर.
हा, स्मिता चौगुले.
Yes, sir.
हा, ठीक. आता बघा, त्याच्या पुढे जातोय आपण. पुढे जात असताना आपण काय करतोय, तर अनबॅलन्स म्हणजे काय, की समजा हा ए आणि डी हे दोन पॉइंट आहेत ना. ए पॉइंट पाशी असणारा स्ट्रेस आणि डी पॉइंट पाशी असणारा स्ट्रेस, ह्या दोन्हीचा ऍव्हरेज घेतला की दॅट स्ट्रेस इज ऍक्टिंग इन दिस डायरेक्शन. आणि बी पॉइंट पाशी असणारा स्ट्रेस आणि सी पॉइंट पाशी असणारा स्ट्रेस यांचा ऍव्हरेज घेतला तर या डायरेक्शन मध्ये जाणारा स्ट्रेस. दोन स्ट्रेस कसे आहेत बघा, बी पॉइंट पाशी असणारा स्ट्रेस आणि सी पॉइंट पाशी असणारा स्ट्रेस, या दोन्ही स्ट्रेसचा ऍव्हरेज घेतल्यानंतर जो स्ट्रेस तयार होतो, दॅट स्ट्रेस इज कन्सिडर्ड टू बी इन पॉझिटिव्ह एक्स ऍक्सिस. अँड ऍव्हरेज ऑफ स्ट्रेस ऍट पॉइंट ए अँड ऍट पॉइंट डी, ए आणि डी या डायरेक्शन मध्ये असणारा ऍव्हरेज स्ट्रेस जर आपण कन्सिडर केला तर दॅट स्ट्रेस इज कन्सिडर्ड टू बी ऍव्हरेज स्ट्रेस in negative x-axis. Is it okay? So positive x-axis and negative x-axis. In both the directions, this average stress that is going to act here. And now what we are going to do? We are taking average of that. Is it okay? So in order to identify the average of that, we should go for the unbalance. Is it okay? So unbalance म्हणजे आता या डायरेक्शन मध्ये ऍक्ट होणारा स्ट्रेस, त्याच्यामधून हा जर स्ट्रेस आपण मायनस केला, या सरफेसवर ऍक्ट होणारा जो स्ट्रेस आहे त्या स्ट्रेस मधून हा स्ट्रेस जर आपण मायनस केला तर जो काय राहिलेला असेल त्याला आपण अनबॅलन्स म्हणतो. इज इट ओके ऑर नॉट? स्ट्रेस ऍक्टिंग इन द डायरेक्शन ऑफ पॉझिटिव्ह एक्स ऍक्सिस अँड स्ट्रेस ऍक्टिंग इन द डायरेक्शन ऑफ निगेटिव्ह एक्स ऍक्सिस, इफ वी टेक subtraction of that and then whatever the remainder, that we will consider as unbalance. Is it okay or not? लक्षात येतोय का? कन्सेप्ट लक्षात येतोय का? येस और नो?
Yes, sir.
हा, म्हणजे काय मला म्हणायचं लक्षात घ्या, एक्स डायरेक्शन मध्ये जो स्ट्रेस ऍक्ट होतोय ना, पॉझिटिव्ह एक्स डायरेक्शन मध्ये, तेवढा स्ट्रेस जर वाय डायरेक्शन मध्ये असेल तर अनबॅलन्स 0 असेल. बट इफ सर्टन क्वांटिटीज आर प्रेझेंट देन दॅट विल बी कन्सिडर्ड ऍज अनबॅलन्स. त्यामुळे आता आपण काय करतोय, तर आपण या दोन्हीचा ऍव्हरेज काढला, म्हणजे बी पॉइंट पासला स्ट्रेस आहे, सी पॉइंट पासला स्ट्रेस आहे, ए पॉइंट आणि डी पॉइंट हे चारही स्ट्रेस आता आपल्याकडे अवेलेबल आहेत विथ इक्वेशन 1, 2, 3, 4 and this particular fundamental reference point. With this we have identified the stresses at point A, D, B and C. Then we are taking the average stress on this surface and average stress on this surface. Is it okay? या surface वरचा average stress आणि या surface वरचा average stress, हे दोन average stress जर आपल्याला माहित झाले तर या दोन्ही मधला डिफरन्स म्हणजेच काय असला पाहिजे? So that will be the unbalance. Is it okay? So in order to identify that unbalance, now what we are doing? We are taking average of xc xb divided by 2, average of xa xd divided by 2, and that values we are substituting here. Equation 1, 2, 3, 4. And with that, if we solve this equation, we are getting dou sigma xx upon dou x dx dy. So this part you have to do as a homework. हा पार्ट तुम्हाला जरा होमवर्क म्हणून करावा लागेल. हा पार्ट तुम्हाला होमवर्क म्हणून करावा लागेल. यू शुड डू दिस बाय युअर ओन हँड. मी या नोट्स जे आहेत ते तुम्हाला शेअर करतोय, तुमच्या ग्रुपवर टाकतोय. तुम्हाला ते होमवर्क म्हणून करावं लागेल. येस ऑर नो?
Yes, sir.
हे सॉल्व्ह करून बघा. हे जे आता आपण म्हणतोय ना इक्वेशन 1, 2, 3, 4, हे सगळं तुम्ही सॉल्व्ह करून बघा. कराल का?
Okay, sir. Yes.
Yes, sir.
Okay. So I will share that notes to you. So with this, I should stop here. Let us have your attendance. Tech structure. Today is 17.
Twenty 22.
Okay, roll number 1. 1 आहे का? Roll number 2.
Yes, sir.
Roll number 3. 4. Roll number 4. की अदर आवाज येत नाही आहे. Roll number 4. Present or not? If present, type in the chat box. Roll number 5. 6.
Yes, sir.
7. 8. 9.
Yes, sir.
10. Roll number 9. 10.
Yes.
11. Roll number 11. 12. 13. 14.
Yes, sir.
रोल नंबर 14 कोण आहे?
Nirai Puja.
जरा वेळेवर जॉईन करा पूजा.
Okay, sir. Next.
उशीर झाला. 15. रोल नंबर 16.
Yes, sir.
17.
Yes, sir.
18. रोल नंबर 18. शेटे रोल नंबर 18 आहे का? असेल तर
नाही.
चॅट बॉक्स मध्ये टाईप करा. हा,
18.
चॅट बॉक्स मध्ये एंटर करा जर कोण राहिला असेल याच्यामध्ये. रोल नंबर 19.
Present, sir.
Okay,
Sir, date 2022.
20.
Hello.
हा,
Sir, one is present.
ओके. रोल नंबर 1 सुजाता बेंगे. ठीक. रोल नंबर 1, 2, 6, 9, 10, 14, 16, 17, 19. Is it okay?
Yes, sir.
Okay. Thank you. Thank you very much.